So one of the things I've been looking at for last week, and this is the reason why I didn't get a video out, so I apologize for that. But sometimes the prep work that I do takes more time than a week to get it done, and that's the case here. So what have I been working on? Well, the first thing is that Ubuntu. I decided to go try the Ubuntu release for the RISC-V. And the reason for that was I just kept running into issues with Yocto. And Yocto is fine if you're doing testing with hardware and you're interested in getting the hardware to work, but I'm past that. I'm not interested in that. What I want to do is to see it work as be able to add packages to it, be able to update and make sure that and harden the system. So what I did last week is I actually took the machine down and I installed Ubuntu on an SD card, and that's where it's at right now. I haven't moved it over to the internal drive yet, but I probably will do that as soon as I'm done playing around with it. But the first thing I want to do is try to get the system hardened, which I did. I was successful in getting that done. I'll show you the score here during this. But yeah, the challenge wasn't so much in getting it hardened. That worked pretty good. The real problem is that it works a little differently and in how your permissions now work. And I think that might be changes that Ubuntu has made in 24.10. This is the first time I've hardened 24.10, so yeah, I ran into some issues with it, and it really screwed up the install of Phoronix test suite because the UMask, because I did the hardening first and then installed Phoronix. Normally I do it the other way around. So yeah, so I had to go and straighten out the permissions. That was a disaster, and of course it wouldn't boot, it wouldn't launch. So yeah, that's not going to help me too much. But the thing, I did get it installed. I am running the tests right now. I'm DJ Ware, and this is the Cyber Gizmo. Today we're going to be doing two tasks. First, I want to take my Mac Mini, which is currently running Asahi Fedora Remix 40, and upgrade it to Fedora 41. And I'm going to use the standard upgrade process to do that. The second thing I want to do is I want to re-benchmark the systems, including the RISC-V. I want to put it to the test. Let's go get started and let's get this M1 upgraded, and then we'll benchmark the two and compare those at the end. Okay, so what could go wrong? I'm going to attempt to upgrade my version of Asahi. Now, currently, I am running Fedora 40, as you can see right there. Asahi Remix. This is the KDE version, so that's what I'm going to attempt to upgrade today. So, if we go out to the docs for Fedora, you'll notice that the first thing I want you to do is this refresh on the repository. So this way it'll bring down a fresh copy of all of the packages, all the package descriptions. So yeah, we'll do that first. Now I've run this, but I'll go ahead and do it again. And you can see it's just refreshing all of the repos. So that, and don't skip this step because there's probably patches in there that's going to be needed for the update. So, okay, let's go down and see what the next thing is. So the next thing is we want to do a download on the release version 4.1. So I'll go ahead and copy that. Yeah, so it's just reminding you, make sure you do that. Yeah, make sure you do that. I've already done it. This will probably take a little bit. There's probably 2,000 packages, maybe. Somewhere in that neighborhood. Yeah, 2726. Yeah, this could take a little while. I'll be back. Okay, so the initial download is done. So now it's asking me to update my keys, and so we'll do that. Now, hopefully, I don't know if it's got any more keys that it wants me to do, but typically it's only going to be one. They actually, okay, so all right, I see what they're doing. So they're gonna do this upgrade as part of the reboot, which hopefully will be faster. And then it says once you're done, to remove any cache metadata after it restarts. We want to do that after. Yeah, after. That'd probably be real good. Bong. Okay. Yeah, my machine is a little slow on starting up, so all right. So now the upgrade process begins. And I will be back. I'll do the waiting for you. Oh, here we go. Looks like we're rebooting. Rebooting. The moment of suspense. Will it come up? Oh, that's a good sign. Oh, look at that. The green screen is gone. Yay. Yeah, I know. I could customize it. All right. Now we got to go do our last task here. We just type in clean. That should do it. I don't think it's said to reboot afterwards. So, all right. So the first thing we probably ought to do is make sure that we have the system fully updated. Nothing to do. Okay. So we're fully updated. The next thing I want to do is benchmark this and see how it is doing. So let's refresh for Onyx. Okay, and do I have the new ones out here? Let me see. Yes. It may have to. All right, so let's talk about some of the new tests and some of the old ones too, because I left some of them in. One of the ones I left in was Botan. Botan is a common cryptographic algorithm. It pulls from a library. It tests the common ones that we probably all know about, like AES and some of those. So it does a performance test against the more common ones. The build Linux kernel is a time test of the Linux kernel. It both builds and compiles from source. So does it really give you, is that really a necessary test to tell you how the performance of your machine is going to go? No, but it does. The kernel build is a good choice because it compiles with a lot of programming languages, because the kernel of the Linux kernel source code is comprised of a lot of different pieces of source code for different compilers like Rust and C and C++, and yep, even assembler is in there. C-Ray. C-Ray is a multi-threaded ray tracer, so and that will require a graphics card to work. So yeah, of some kind. FFmpeg is a modified version of the vBench. It says bench, but it's vBench. And I think this came from Columbia University is where that originated from. I'm not sure if it's the same V-Bench that Oracle is working on, but it might be. I just don't know. HPL is a high-performance LinPack. It can, if you have clusters set up, it can run in clusters, but it does two different things. The first one is it does a dense 64-bit double precision math test. So it pulls in a bunch of functions out of the math library and runs them. And then it culminates with a LinPack test. And LinPack, as you probably know, is the more famous. There's various variations of LinPack, probably as many variations as there are locations in the country that run supercomputers. They all seem to take it and modify it to their own. So LinPack is a way to test TOPS, the proper way. So yeah, typically TOPS is computed with double precision floating point arithmetic. And that is what LinPack does. LuxMark is a cross-platform benchmark of graphics that uses OpenCL. So it requires an NVIDIA graphics card to run, otherwise it will fail. But MBW is a memory bandwidth benchmark. So it's going to try to measure the amount of bandwidth that your memory can support. It's going to try to push it. PHP Bench is a PHP scripting benchmark, and it's pretty well understood. I think there's a PHP JUnit, which is used to test a PHP compiler's correctness. The PHP benchmark is the performance side of that, so it goes through those same JUnit tests, only it tests each one for performance. RAM speed is memory and cache memory performance test, so it's a good one to try to give you some idea of how your system will perform real life, but again, it's a synthesized test. Speed test CLI, I'm not sure this one's useful, and it's an old test, so I'm not sure I want to hang on to it. It's an internet connectivity test. I think that's meaningless unless you are accompanying this with tests that are going to try to measure latency or jitter or 100 other variables, probably 1,000 different variables in your network to conclude whether or not your card and driver are good performers. But that test, I don't think I'm going to include it going forward. StressNG, we have used this before. It's a kernel level stress test. It goes through a lot of the syscalls, and this is not a benchmark. This is trying to break your kernel. So it's always a good idea to try to run this to make sure that the version of the kernel you have is stable, because the last thing you want to have happen is you're in a real busy mode. The machine is just hammering away. There's sys requests flying all over the place, and all of a sudden, boom, black screen of death. Yeah, you don't want to see that in Linux. That's not a popular thing to want to see. Tiny MBench is a simple memory test. It tries to measure peak bandwidth, so it tries to push all the way up to see what the maximum bandwidth would be. Kind of limited, but it's a tiny benchmark, and it's probably good to include here. YCruncher is a multi-threaded pi calculation benchmark, so you can tell it how many decimal points you want to calculate, and then it'll time it. LibreOffice tests various LibreOffice operations. So yeah, OpenSSL has a built-in benchmark that's a part of the suite of applications that come with OpenSSL. And so this benchmark is meant to exercise the SSL and TLS algorithms within the OpenSSL libraries to see how well they're performing. Pavre is called the Persistence of Vision Ray Tracer benchmark. The Pavre people have a very specific image that they generate using It generates 3D graphics that are ray traced. They prefer you to do that. I'm not sure if Phoronix is using their recommended benchmark to do this with. For Botan, I think the only ones I'm really interested in is AES and Cha-Cha. Those are really the two that are probably the most widely used in Linux today. Okay, kernel build, we're going to do the definition, default kernel build. Processor test for C-Ray, we'll do 1080. This machine doesn't have capability for 4K. I don't have a 4K monitor here, so that's the only reason I'm doing it. I'm going to do unkeyed algorithms. Keyed algorithms doesn't seem to work. And since we're doing a 1080 test, we'll constrict FFmpeg to x264. This may or may not work. I don't know. We're going to do a platform test with that, and then for MBW, we'll do a copy fixed block size for that one, and we'll test 2 and 3. And this one, of course, we'll do. I think the only one I need to do is triad. Test floating point, and we'll do triad on the stream test too. And then 1 through 12 on this is the stress test. I know because I've done this several times. Yeah, so we're going to test CPU, crypto, mem, glib, vector, matrix, forking, system 5, semaphore, socket, and context switching. So, yeah, I understand that there's some changes that are coming for context switching, so that'll be interesting. 4 and 5 are the only ones I'm interested in here for the OpenSSL. I'm trying. I mean, I could put RSA in here, I guess. All right, let's do that. Let's do that. Okay, so would you like to save these tests? Yeah, I guess. I'll make this the third test, and we'll call this is Fedora 41, and we don't need anything else. This will probably take about, I'm going to guess about 3.5 hours. Oh, 2.5 hours. I will publish these when I'm done, and then we'll look at the results and compare them to the other machines that I have tested already. So I've got 7 machines here that I tested. I have, this is the Ryzen 7700X with a NVIDIA RTX 3070 graphics card. This is the Intel Meteor Lake. This is running Fedora 40. This is Snapdragon X Elite, and this is running Ubuntu 24.10. This is a Mac M1 Pro laptop, and this is running Fedora 41. This is Fedora 41 on a Mac Mini. This is Fedora 41 on a virtual machine. Let's go ahead and look at all the tests and kind of make our conclusions from here. Place the AMD Ryzen 7700X. And then I would say the Fedora 41 M1 Pro is next. Then I would say there would be the Snapdragon would be in third. The Meteor Lake first, then the Mac Mini, then the virtual machine. So let's look down here at the CPU tests. And this should be in fairly the same order. We have the Ryzen, then the Mac laptop. It's an M1 Pro running Fedora. Close behind, very close behind, is the Snapdragon X Elite. Then we have Fedora 40 on the Meteor Lake, and I just haven't upgraded this one yet. I'll get to it, but I just haven't done it yet. Fedora 41 Mac Mini, and then Fedora 41 Virtual Machine. In cryptographic tests, again, these 3 are very close. So, which is surprising that the Snapdragon, this is a laptop going against a desktop. So, yeah, this is CPU testing, obviously, but Yeah, it's pretty impressive what the Snapdragon is able to do. It does have more cores, though. The Snapdragon has 12 performance cores, whereas this one has 8 with 8 threads, 8 additional threads. So you get 8 cores, 16 threads. The Meteor Lake is, I don't. I would. It's in the ballpark here, but I would put it clearly in third here. Just going down, these two are close. This is not so close. Then the older M1 Pro, M1 Mini, Mac Mini are very close in this test. Common kernel benchmarks, this would be Stress NG would be part of this. So this is actually testing different functions within the kernel. And the geometric CPU tests, Ubuntu is 161 times faster in the single threaded test. Yeah, so 21 out of 38 tests, the Ubuntu 2410, followed by Fedora, which got 6. Now, that doesn't mean that this is terrible. It just means that this one scored first on the 38 tests. 21 of those 38 tests, this was the highest score. Whereas 6 of those 38, this was the highest score on the Meteor Lake, then 5 for the M1 Pro. So yeah, and then of course we don't even see we don't even see the RISC-V. It was dead last, almost 26 out of 38 times. Yeah, that's where things stand. So I would say it's been a long week in trying to put all this together. I did not realize that the Ubuntu was a real-time kernel that was running on the RISC-V until I got all the way through the test, started to look at, started noticing, and you probably saw it too, during the course of the video, RT, when you see that, is real-time. So, yeah, kernels that are written for real-time processing need a completely different set of workloads. They don't perform well in a traditional environment of Linux using conventional workloads. They will perform poorly, as you can see from the benchmark results. So just disregard that. I'm going to go back and see if I can find a conventional kernel that I can use. I'm not sure that Ubuntu is ever going to release anything along that line. Their intention for this board is for automotive. And yes, you probably would want a real-time kernel in that kind of a application base. So yeah, I don't know if I can substitute that real-time kernel out. I should be able to. And then rerun the benchmarks and see what I get with a conventional workload on a conventional kernel. So, yeah, this is the reason why I always, when I'm pointing at, people are talking about, how was a real-time kernel going to perform on my favorite game? Probably like that, terrible. So yeah, don't use real-time kernels for conventional processing. Bad idea. Use real-time kernels for real-time applications. As far as performance of overall, I don't think there was any surprises that the desktop won most of the time, but there was some surprises. The Snapdragon X Elite did quite well in these benchmarks, and I'm kind of surprised. I mean, I know the M1 was such a huge step up as a performer from the beginning that it's taken Apple 4 times to beat it. So, I mean, the performance gains with the M2 and M3 were okay. They were, they're incremental or evolutionary gains due to probably the die size for the chip and the gains that you get from that. But the M4 is a game changer. It's like 2 times faster in processing, so it is a big step. Anyway, that's all I had for today. I wanted to cover what I was planning on doing, and I did manage to get the RISC-V up and running on Ubuntu. But I hope you enjoyed the video. I hope you enjoyed the benchmarks. Let me know in the comments below what you think might be a good addition to add on to this while I'm working up a new solution. I have two different parameters for this. One, I want to be able to cover a wider ground to give you more of an idea of how well the distributions will perform in different use cases. The second thing I want to be able to do is to try to get away from the 4-hour runtime of this benchmark, because as you can see, that's a half a workday just to get one machine done. And yes, you can run them in parallel the way I have things set up here, but provided it's on hardware. If I'm trying to run them all on a virtual machine, no, I can't do that. I only have one VM host. So, yep, and that's all I can do for right now. That's all I have. Hope you enjoy the video. Hope to see you again soon. Please like and subscribe, and bye for now.